Good evening, guys. Thanks for joining. Please wait for 2 more minutes. Let others to join. Thank you. Sir, NPTEL class. NPTEL class போயிட்டு இருக்கு. அப்டேட் பண்றேன் சார். Okay. So good evening, one and all present here. We'll start the session. This is Saravanan, Prime Minister Research Fellow and a PhD Scholar of Department of Civil Engineering, National Institute of Technology, Tiruchirappalli. As a part of PMR of deliverable, I have to take 1 hour of TA work in nearby colleges or in NPTEL. So, as a part of PMR of deliverable, I am taking NPTEL Municipal Solid Waste Management course and assisting as a TA for Dr. Ajay Kalamdat sir in NPTEL. So, this is a problem solving session, and first 1 hour will be we are going to discuss about the same presentation that sir has explained in the NPTEL videos, and next 1 hour we are going to discuss the old assignment problems. Um, this is the fourth week we are going to discuss. First week we have discussed about the solid waste management basics, how wastes are generated and what are the types of waste and how to segregate the waste. And then in the second lecture we have discussed about how to collect the waste, what are the different collection mechanisms. And in the third week we have discussed about the some of the problems related to designing the collection system, that is the secondary collection system. And this week we are going to discuss about the transport and the MRF facilities. MRF is in the sense material recovery facility, that is coming under the processing part. Yeah. So this is the broad introduction. Yeah. Can we recall the formulas once what we have discussed in the last week? That will be helpful for you to recall once. Yeah. So we have discussed two collection system. One is a hall container system, another one is stationary container system. So in hall container system, the whole container will be hauled. In stationary container system, the container will be there. Only the vehicle will move from one location to another with collecting the waste from the container. Okay. So this will be assessed based on time only. So every formula have the unit in terms of time per trip, that is hour per trip. So what is the time required per trip will be based on pickup time. Pickup time consists of picking the container, unloading the container, and traveling from one container location to the another container location. That is, the summation will give you the total time per trip, because in hall container system one trip is equal to one container emptied, but in stationary container system traveling from different locations and then moving to the disposal site is considered as one trip. So the formula will contains everything, not the one container that is emptied. Okay, yeah. And then the pickup time will be the summation of this three. Halt time will be based on another empirical formula, that is a plus bx. A and b are the empirical constant, and we have 8 hours per day as a working hour, and w is the off route time, that is 15% will be used for unnecessary activities. Then t1 and t2 are the time required to travel from the lorry garage to the first location, and going from the last location to the lorry garage or a vehicle carriage. So these are all the time we need to subtract, and finally the total available time divided by number of time required per trip will give you the number of trips we can cover. And in the third comparison, we have compared how much labor required for stationary container system and the hall container system. Or in the hall container system itself, if we have change one parameter, what will be the labor requirement change? So we concluded for one scenario, like one container with one person, one person crew will be optimal compared to one vehicle with a 2 person or 3 person crew. In the same sense, a large container compared to a large container, smaller container gives a more optimal results. That and all we have discussed based on the labor requirement. Labor requirement is simply like number of collector into the same formula what we have used. So just to interchange, you will get different formulas. That are all discussed in this single slide. You can just print the slide and you can go through. It will be very easier. You can take any notation and put it on your own. Will give you the result. Okay, just note down the units. Pickup you can say as P, unload you can say as U. So they have given this notation. You can use any notation. Okay, this is what we have discussed in the last week. Yeah, moving on to this week. So first week we have discussed about waste generation, second week storage and collection, third week some of the problem related to collection, this week transport and processing we are going to see. So transfer station we have discussed, and what is transport? Transfer station we have discussed three types. Transfer station, first, what is transfer station? If we are going to dispose the waste from the collection location to a far location, if the landfill site or a disposal site or a MRF facility is available very far from the collection site, then we need an intermediate point. Then a smaller vehicle will collect the waste and dump in the transfer station, and from there a larger vehicle will collect the waste and it will dispose in the disposal site. So there plays transfer station a major role, and it will reduce the cost of transport, because collection and transport itself will constitute of 95% of the total cost incurred in solid waste management. So to reduce the cost of transfer and transport, we are using transfer stations. Okay, so transfer station again comes in three types. One is direct load, another one is like the storage load, another one is combined direct and storage load. Direct load in the sense, a smaller vehicle will directly dump into the larger vehicle. So many smaller vehicle will come and they will dump into the larger vehicle. In a storage transfer station, storage load transfer station, the smaller container will dump the waste in the platform. From there, whatever the recoverable item we could get, that and all will be segregated. Finally, it will be transported into the larger vehicle. If in a combined system, both direct and storage load will be there. Okay, now we are going to see about the transport. Yeah, one second, I'll reduce the size. Yeah. So transport, we have different vehicles, motorized vehicles for transport. In a large scenario I am talking about, we have lots of motorized vehicles having pneumatic and hydraulic jack for loading and underloading the waste. So in the means, these are the different types that you can see in the photos. This is a large truck used for transport of municipal solid waste, and this is a truck with hydraulic system at the back. This is a back load truck, back end load truck. So major thing we have to design, we have to satisfy or the cost. First, the cost should be minimum for any transport system, and it should whatever the waste that is collected, that should be accommodated, that should be covered within this transport vehicle. And then it should be the vehicle must be designed for the highway traffic. It should not be very big, because if we need to take any U-turn, this type of larger vehicle can't take any U-turn in the highway traffic. So the vehicle should be designed in such a way it should handle the highway traffic also. And allowable weight limits for the, if it is a power block load, instead of this type of bitumen road can, bitumen road or a concrete road can withstand heavy load, but some type of power block can't withstand heavy load. So allowable weight limit, allowable height limit, some roads will have some height limits, that and all taken care before designing any vehicles for transport of solid waste. And the method of unloading should be simple and dependable. It can be manual or any mechanized, like hydraulic jack should be there to load and unload the waste. And then what are the types, types of transport we can use? One is first roadway. This is roadway, that is the normal thing we are using in Indian subcontinent. Like railway transport of solid waste is also there in most of the developed countries. It was initially used in India. In the past, we have also using railways for the transport of solid waste. So because whenever the landfills are located in the remote areas, the waste from the urban area should be transported to the remote locations. And then ocean going vehicles are a seaway transport. Initially it was used because once the sea disposal or a ocean disposal option was there for solid waste management, they will dispose the whole solid waste in the underwater. They will seal and they will dispose into the underwater. This type of disposal facility was there initially. That time they have used seaway transport. Now also people are using seaway transport to transfer from solid waste from one location to another. Or most of the plastic recyclable plastics are disposed in different countries through seaways only. You can last year I have taken plastic waste management course. In that we have discussed about the recycling pathways of different plastics. In that, China was the biggest contributor for the plastic recycling. So they will take all the plastic generated worldwide and they will recycle, because they do not rely on virgin plastics again for their product, because China is the major producer of plastic. So they need raw material to manufacture plastic. So they depend on waste plastic to manufacture to create a raw material for virgin toys, whatever the plastic item they are going to make. So like that, the transportation will be through seaways or ocean ways. Yeah. So here also you can see a river. Thames River in England was used as a seaway transport for solid waste. The use is like a processing location, and to see if it is a seaside area, then we have to rely on only the ocean way transport. Okay, so it is difficult to use barrage and boats during high sea conditions. So there are some of the demerits related with the waterway transport. Then what are the systems we can use, like pneumatic and the hydraulic systems? Pneumatic in the sense it will suck the waste and it will transport to some of the, like vacuum we will use to transport the waste. Then hydraulic system in the sense it will use the you know what is the hydraulic hands and all you can see here. So that will push the waste up and it will also load the waste. So here we have a separate machine that will pack the waste and it will load into the truck body. Similarly, semi-trailer hydraulic pump for waste transport in Italy, and a lot of things you can see in Disney World in Florida. You know about Disney World? They are the largest pneumatic system transporter of solid waste that is located in Disney World only. Largest pneumatic waste transport system, and this is also one of the pneumatic transport system only. If you put the waste here with the underground long way pipe, it will reach the disposal point. Okay, like kind of pump we'll use to take or extract the waste, and it can be controlled with the tubes and generate a suction force that applies a negative pressure to the mouth of the tubes. Yeah. And what are the requirement for a transfer station? This is again we are going to transfer station, because whatever the transport we have used and the waste is again loaded into the transfer stations only. So what is the requirement for different transfer stations? So we have different criteria. First one is what are the operation it going to do? Like what if it is going to do a recovery? Because transfer station may act as a material recovery facility also, MRF. So what is the waste we are going to recover, and keeping on mind the adequate area should be allocated for unloading the waste, and then storage and the throughput capacity requirement. Then what are the uh, one second. So, one sir. Oh, one second, sir. Thank you, sir. Yeah. So regarding the equipment and accessories required for the transfer station, we can design. It may be a direct load, means no much like equipments are required. If the smaller vehicle will directly dump the waste into the larger vehicle. But if it is a uh, pit storage or a storage load transfer station, we need a pit, and there should be excavator or a loader to take the waste and load into the bigger vehicles. The hopper is required, a tube kind of structures are required. These are all the equipments and accessories requirement we have to think before designing a transfer stations. And the scales in the sense the weighing balance. Weighing balance is must to design I mean in any transfer station, because not design like to monitor the how much waste that is coming into the transfer station and how much waste that is getting out of the transfer station. That is mass balance we can do with the weighing balance only. Okay, the facilities for the equipment maintenance also should be provided. Another one is like whatever the equipment there, we need maintenance and the operation. So other than the construction cost, we need operation cost also. Then these are all equipment necessaries. Then environmental requirements like air handling equipments that should create negative pressure. Again, it will create energy requirement, and that will create another environmental carbon footprint. And construction should be fireproof with open loading areas in direct load transfer station, because it will be directly loaded into the platform or a bigger vehicle. So the accumulation may generate methane emission that will catch fire easily. So the construction should be fireproof with open loading areas. Then it will be easy to handle the fire if anything happens. Then the sanitary requirements for the workers or the laborers, and also for the public nearby. This is like for maintaining proper sanitation. Spilled solid waste should be picked up immediately, because while loading or unloading, many spillage may happen. That should be immediately taken care within and allowed to accumulate not more than 1 or 2 hours. In larger facilities like wastewater treatment should be there, because whenever we are handling any solid waste, there may be any leachate generation. So that leachate should be taken care separately, and it will be treated in specially designed wastewater treatment plant. And some may have particulate matter emission that should be handled separately, and there should be a proper net fence at the boundary of the transfer station. Then we can avoid the flying of this plastic cover may easily fly, and it will contaminate the nearby area. So we should avoid this type of things by proper fence around the transfer stations, and there should be a local sewer to collect the leachate generated. Then health and safety of the workers, they should be provided with the proper mask, because particulate matter may emit. So dust inhalation proof. Overhead water sprayers that will again overhead water sprayer will always spray water that will settle all the particulate matter that is emitted. And air conditioning and dust filtering units, public should not be allowed to discharge waste directly. That is the important point. So if we construct any transfer station, simply people will come and directly discharge their waste into the transfer station. That should not be there, because again it will collapse the whole mass balance system. Whatever the waste that is collected by the municipality should be unloaded in the transfer station. There should not be any direct disposal by the public. Yeah. And the location of transfer station. This is again a major point because the cost is directly based on the location of the transfer station. It should be near to the weighing balance because whenever we need to go to the weighing balance, then only we have to enter into the transfer station, and it is easily accessed with the highway routes because the vehicles may be very big. Bigger vehicles will come, smaller vehicles will come, so it should be easily accessible. Minimum public and environmental objections. Any public will object construction of solid waste facilities near their premises. We won't allow any incineration plant or transfer station nearby our houses. Like that, public won't allow. So minimum public objection, and the area should be very. I mean, it should not be any what we call like buffer zone. There should not be any hospital. There should not be any heritage structure. There should not be any waterways that should be polluted. So minimum public and environmental objection, and in the same way, it should be economical also. It should not be far away from the urban area or a rural area. So it should be at the outskirts of the city. Then it will be easy to access. And because transport cost is directly based on the location only, minimize the transport cost. Operational constraint will be 2 or more transfer station can be possible to handle different types of waste. One for wet waste, direct load system, and one for dry waste. We need a MRF kind of thing. We have to store the waste and we can split into different things. And then combined load will work better because that is a 2 or more transfer station system. Combined direct and storage load system to handle different types of waste. Yeah, that also need to be taken care while finalizing the location because area requirement again plays a major role. Yeah. So again, some of the mathematical assumptions and the criteria need to be considered for transfer station design. If you see, these are the 3 transfer station. T is the transfer station 1, transfer station 2, and transfer station 3. And we have different disposal point D1, D2, D3. D is the disposal point, and X is the what we call amount of waste that is transferred from the transfer station to the disposal area. So if we X to 1 in the sense, it will be transported from the second transfer station to the first disposal point. So that is the amount of waste. X is the amount of waste. C is the cost required to transfer the waste from transfer station 2 to disposal point 1. Yeah, and the basic assumption is mass balance. So amount of solid waste that should be hauled to each of the 3 disposal sites from each of the 3 transfer stations, so that the total hauled cost will be minimum possible value. That is the criteria we need to wherever how much amount of waste that should be handled from T1 to D1 and how much of amount of waste from T2 to D3. That and all mathematically we have to calculate, and based on that the cost mathematically calculate in the sense the haul cost should be minimum. Then only this system we have to adopt. Yeah, the 3 basic assumptions we have to take. One is the mass balance. Whatever the amount of waste hauled, which is equal to the amount of waste delivered to the transfer station. So as a municipality, I am collecting 1000 kg of waste. Then 1000 kg of waste will be transferred to the delivered to the transfer station. That is the mass balance. And whatever the amount of waste transferred from the transfer station to the disposal sites should also be equal. And then the specified amount of waste can be accepted in all the 3 disposal sites. I assume from the transfer station 1, some part will go to D1, some part will go to D2, and some part will go to D3. So all the 3 disposal sites will get some waste from transfer station 1. Similarly, from transfer station 2, all the 3 disposal sites will have some waste, will get some waste. Like that, that is the specified amount. That is one of the assumption I am going to give. And then the third assumption is the amount of waste hauled from each transfer station is equal to or greater than 0. So there must be some waste that is hauled. It should not be negative in the sense the transfer station should not receive any waste from the disposal site. Always the waste will be hauled from the transfer station because again if I am 100 kg of waste is in the transfer station 2. Some may be going to D3. Again from D3 to T1, it should not get any waste. Only the way will be from transfer station to the disposal site. That's what mentioned in the third point. always it should be in the positive side. The transfer station will give the waste. It will not get any waste from the disposal side. So with this three assumption, I am going to frame three mathematical rule. If I feed this mathematical rule in any Excel or any kind of software, I will get the amount of waste that should be transported with the minimum cost. That's the final objective. Cost should be minimum. Yeah. So the first objective function is like the amount of waste multiplied by the cost of cost required to transfer the waste from first transfer station to disposal point 1, then first transfer station to disposal point 2, then second transfer station to disposal point 1. Like that, I am summing all the cost and cost per kg into amount of waste, then kg into rupees per kg, again it will be rupees only. Okay, so if I if I do summation of all this thing, I'll get total cost. My aim is to minimize this value with the following three assumptions. First assumption is always amount of waste hauled to disposal site must be equal to the amount of waste brought to the transfer station. If transfer station is 1 is getting 100 kg, then total amount of waste received in the disposal site will be equal to 100 kg only. That is, a summation will give you the total station, I mean the total quantity received in the disposal site. That is the first assumption. Then second assumption is the total amount of waste hauled from the transfer station must be equal to or less than the capacity of the disposal site. If I am having 100 kg, the disposal point is only 50 kg capacity, then I can't send all the 100 kg to the disposal site. 50 kg to first disposal site, then 50 kg to the second disposal site. That is second criteria. It should be less than. But the transfer station should not receive any waste. So it should be greater than or equal to 0. Always in the positive side, it will not be in the negative side. Then if you feed all these formulas, then with the microcomputers, we can get, with the aid of microcomputer, we can get a proper allocation of waste. That is called allocation. Allocation of waste from one transfer station to the different disposal site with the minimal cost. And another one appropriate solution methods available is with the 10% of accuracy, not accuracy, 10% of error can be acceptable. Close to 10% of the optimum level is in the real way practice is acceptable. Okay. Yeah. So, but a proper consideration for setting up of transfer station was given in the CPHEO manual in India. CPHEO is like Center for Public Health and Public Health, Environment and Environmental Organization in India, having a manual for different criteria for setting up of transfer stations, which mention the disposal site should always be 10 km away from the city boundary. This is the main criteria. It should always 10 km away from the city boundary because of the public health concern, and smaller vehicles are used for transportation. But this is again a problem. If it is a smaller vehicle used for collection, then it is economical to have a transfer station. Then from the transfer station, the bigger vehicle will transport waste from the transfer station to the disposal site. Then larger size containers like 15 to 20 meter cube can be kept in the transfer station. It will be the smaller vehicle will unload and is dumped, compacted, then transferred to the disposal site. Construction should not be complicated and it should not be expensive. This kind of conditions should be avoided. And the requirement of large container vehicle must be estimated, and the number of trips can be calculated based on the formulas we discussed in the last week. Yeah. So as of now, we have discussed about the transfer and transport. Now we are moving to the processing. Processing in the sense wet waste processing and dry waste processing. In processing, we are not going to discuss any of the volume transformation. I am receiving 100 kg of the waste. After some treatment, it will reduce to 10 kg. That is called transformation. But processing in the sense, whatever the waste, I am going to simply or physically, I am transferring its size or shape. That is called processing. In the sense like shredding, washing, cutting, and baling, I mean compacting. These are all processing of waste. For wet waste, it is very required. We are going to discuss about the material recovery facilities and all below this topic of processing only. Yeah. So that is the unit operation process. What I am going to discuss about what is unit operation and what are the components. So in India, mixed waste cannot be treated. As we all know, that is we are following two bin system. Say no to single bin system. We are having two bin system. These are the basic criteria for segregation of the waste: dry waste, wet waste, green bin, red bin. And then another basic criteria is three color. One is green for biodegradable, red for non-biodegradable, yellow for hazardous waste. These are all three bin systems. In India, we are following two bin system, that is dry and wet waste. So mixed waste cannot be treated. So waste should be segregated in the source itself. That is the point I am stressing from the first week onwards. Source should be waste should be segregated in the source itself. Then biodegradable waste can be deposited in vacant land for composting, and non-biodegradable waste should be transferred to the MRF facility for recycling. Yeah. So as we know, biodegradable waste or wet waste can be composted and used as converted to compost through the process of composting or anaerobic digestion. But what can we do with the dry waste? Dry waste in the sense non-biodegradable waste, which constitutes different kinds of waste. I'm going to discuss in the next slide. What can we do with that? These are all the different dry waste, household dry waste from the municipal solid waste, cardboard and papers, paper packaging material, glass, then plastic itself, we have number 1 to number 7. I am going to discuss what is number 1 plastic and number 2 plastic. These are all the code we are giving for the plastic. What is number 1 code denotes, what is number 7 code denotes. And then paper, newspaper, magazine, aluminum and steel cans. These are all dry waste, household dry waste, that is municipal solid waste, household dry waste. What we are going to do for this type of dry waste? First processing is like we can do two things in separation itself. We can do two things. One is source segregation. Manually we can separate in the source itself, glass separately, paper separately, metal separately, aluminum tin separately, cardboard separately. But if it is reaching the material recovery facility as a commingled waste or a combined waste, then we can also segregate in the MRF facility, like manually or yeah manually or mechanically we can segregate the dry waste in the material recovery centers. So that when we are segregating using mechanical means, then it is called unit operation. So unit operation is the one with which the waste or the dry waste are segregated mechanically. When the waste is generated at a high quantity, then we are using mechanical way for the segregation of waste at the MRF, then it is called unit operation process. Yeah. So the first processing thing we are going to do is size reduction. So it is difficult to handle bigger waste that is generated in a huge quantity. So we have to first reduce the size of the waste. So for size reduction, we can use hammer mill or any kind of mill. Milling in the sense we can have hammer and a shaft that will rotate and it will hit the waste and it will be reduced into smaller sizes. So the processing of mechanical reduction of size the process of mechanical reduction of size is called milling. This is the milling process. So why we need to reduce the size? It will reduce the storage area and the shipping cost. It is not the volume reduction process. It is simply the size reduction process. Understand the difference between volume reduction and the size reduction. Because if I am putting 10 kg of kitchen waste in the backyard, tomorrow I will see only 5 kg because most of the waste will be degraded and it will be converted to carbon dioxide and only 5 kg is left as compost. So this is volume reduction process. But here I am not doing any volume reduction. I am only doing size reduction. So again 10 kg of the waste will be 10 kg only, but the size will be reduced and the total volume of storage will be reduced. Yeah. So different types of shredders are hammer mill, flail mill. You can see the different kinds of mechanical tools or equipment used for shredding. This is a shear shredder. Shear shredder is used for cardboards and the wires, and some of the steel wires can also be shredded with the shear shredder. This is a glass crusher. This is also a shredding machine, but for glass. Then we will call as crushers. Then wood chippers for agricultural waste and tree cuttings. We will use wood chippers. This is the industrial wood chipper. So first with shredding. Then second the processing thing is screening. Screening in the sense, segregation of the waste based on its size. So separation of mixed waste into different based on different sizes. So different screen we are using in the field or vibrating screen. Vibrating screen, it will simply vibrate, and based on the hole size the waste will be segregated. This is a rotary screen. Rotary screen will have meshes of different sizes. First will be 2 mm, 6 mm, and then 10 mm. So the waste will be lesser than 2 mm will fall out here, and then 5 mm will fall from here, 10 mm will be falling from here, and greater than 10 mm will come out of through this way. That is a two large particle. Then we will get four separated materials at the same time. This is a disk screen. Similarly, we have star screen and ballastic separator. Ballastic separator are separation based on dimension. One dimension paper, two dimension plastic, cardboard, three dimensional plastics are all removed with ballastic separator. It will simply shake and the waste will be removed. Yeah. Then third type is density separation. Density separation is majorly used for um, uh, uh, lightweight particles like plastics and papers. So the it is based on the density of the waste. So the waste will be fed from this way, and here a blower or a fan will be there that will flow air into this along with the waste. Lighter particles will flow along with the air, and it will reach the separator. But the heavier particle will not able to follow the air path, will fall from here, and it will be collected separately, like heavier metals, heavier HDPE plastics will all be collected. Lightweight plastics will blow from here, and it will be collected in separate chamber. This is simple density separation process. Then magnetic separation, as you know, it will be used for separating ferrous material. Separate tins and aluminum cans can be separated with this type of magnetic separator. Like overbelt magnetic separators are there. Simple hanging magnetic separators are there. It will simply like we can induce some electricity. The field will be induced, and the magnetic field will be induced, and the iron or ferrous material will stick to the belt, and it will be taken to the separate containers. Yeah. Then densification is another process which will reduce the volume of the waste, not by physical means. You can see aluminum can be compacted into this type of coins. So it is easy to transport now. You can't transport 100 aluminum cans, but when you can easily handle 100 coins kind of thing, this like this. So after crushing or densification process, we can easily store and transport the waste. So another baler or can crusher. So if this type of agricultural waste can be rolled into a cylinder kind of thing, and it can be easily transported and stored. Yeah. So after densification, it can be also used as a refuse derived fuel. Whenever we are getting any organic waste which is having calorific value, then we can easily press it into a pellet kind of thing or a briquette kind of thing that can be easily used as a fuel for villages as a cooking fuel. Instead of wood, we can use that as a fuel after densification. That is called the refuse derived fuel or RDFs. This and all now the processes we are going to we are using for solid waste management. One is shredding, one is screening, one is compaction, one is densification, and another magnetic separation, then air classification. Now what are the facilities required for handling and moving and sorting of municipal solid waste? So for handling itself we need sophisticated equipments for solid waste management. First one itself, conveyors. Conveyors are the like our nervous system for solid waste management, because without conveyors we can't transport any type of solid waste inside the management facility, like refuse, MRF, or in legacy waste management in landfill mining also we are using lots of conveyor belts for transporting waste from one place to another, and also different conveyor belt will handle different types of waste. Yeah. And this is another equipment, that is the front end loader, which is used to push the waste from one end to another, and forklifter is used to store the waste. After compaction it can be easily used to lift and store at a separate place. In industrial process and all, this type of forklifters are very much useful for handling the products, but the same is used in the solid waste management handling also. Yeah, solid waste handling also. Then weighing scale or weighing bridges. This is again required for mass balance. We need to monitor each kg of waste that is coming into the premises and getting out of the premises. Also, weighing balance are used to calculate the density of the waste. So as we know the volume of the container, then empty waste of the container and full weight of the container will give you the difference, will give you the total quantity of waste present in the container, divided by the volume of container will give you the density of the waste. If it is 10 meter, this is I mean 5 meter cross 2 meter cross again 5 meter, then the waste present, the amount quantity of waste present in the container divided by the volume will give you the density of the waste. Yeah. Then storage facility. First, we have discussed about the equipments, in the sense conveyors, movable equipments, then weighing balance and all. Then storage facilities. Storage facilities we require whenever the waste is densified or compacted. Until its transport, we need some storage area or a storage facility to store the waste simply before transport. This type of shed is required. This type of concrete platform is required to prevent the leachate that is coming out of the waste. In most of this type of MRF facilities, we won't use any wet waste. Only the dry waste is handled. So there is no possibility of leachate generation. Still, for a safer side, we need to use a concrete pad and a shed. Yeah. So you can go through this video for mechanical segregation of solid waste in Poland and how the waste is handled inside the MRF facility centers. Yeah. So now we are discussing about the processing of the solid waste inside MRF. That is the material recovery facility. Material recovery facility is the name we are using in India. But if you are going to developed countries like US, they are using the word like drop-off points or buyback centers. So drop-off point is the one where we are going to dispose our recyclable materials, and buyback centers are the one we are going to get the processed recyclables for our own use. So this is like a win-win situation. Whatever the people think that is a waste, so they are giving and getting some money, and those who need this waste, they will pay and get back the waste to use as a raw material for their process. So this is like a again full circular economy system. Recycling facilities like drop off centers are the one which is installed, are mobile collection stations, easy type of collection, because no need to go to any households to collect the waste. It is simply like the people will come and drop their own waste in the MRF facility itself, or a drop off point. Drop off in the sense they will simply drop the waste and they will get the money. So in the photo itself, we can see metals how much, plastics how much, cardboard how much per kg. So if you are giving 100 kg, I mean 10 kg of cardboard, and you will be paid this much per kg, like that, we can easily drop off and we'll get some money. Buyback center in the sense people will get that submit, I mean dropped cardboard boxes, and they will pay some money to the center. They will use this for the some other purposes like packaging or any kind of purpose. They will use the same cardboard. So they will purchase clean recycled materials, recyclable material. If we dispose it along with the municipal solid waste, that will go to the facility and that will be again segregated. It may get some contamination, but in drop-off facility, only the recyclable will come. So it will be pure or clean cardboard or clean plastic. So we can easily buy quality products from these centers. Yeah. Another one good idea is to combine the drop-off points along with the shopping malls. So if you have any room or a space allocated for drop-off points in the shopping mall itself, then when the people coming to the shopping mall will drop their waste, whatever the plastic or the cardboard box, and they will buy something as incentives for dropping off their waste. And it will be easy to manage the waste inside the shopping mall itself, the cardboard or the plastic covers, what they are getting from the thing, they are again dropping at the same place. It's again a circular economy kind of street management. Yeah. Here MRF, the material recovery facility. In India, we are using the word MRF, material recovery facility. It will receive the waste, it will separate the waste, it will prepare the waste and prepare the recyclable item for marketing to the end use manufacturers. This is the whole concept rolling behind MRF. So whatever the waste in a clean form it will receive, it will separate the plastic, paper, metals and the glasses, and it will prepare the recyclable item in a way it can be marketable, not the waste as such. It can be a pure paper or a pure cardboard or a secondary product that can be marketable to the end users manufacturing thing. So another video you can go through the lecture or you can go to the YouTube, you can see this type of videos. Yeah. So again in this MRF itself we have different types. One is clean MRF, another one is dirty MRF. Clean MRF in the sense it will receive the source segregated recyclable items. In the home itself we are segregating and sending to the MRF facility, then it is called a clean MRF. And clean MRF itself we have different types. One is single stream, only recyclable, all the recyclable items are mixed. Dual stream, it will receive glass, ferrous, plastics and all. Mixed paper stream, it will only receive the paper kind of recyclables like cardboard boxes, newspaper, magazines from the offices. Okay. What they will do, first they will sort the papers, like a paper, cardboard or which paper or which plastic they will separate first. They will bale in the sense packing this kind of bundles, that is baling, then shredding, crushing, compacting and preparing for shipment to the market, because there is a huge market available for buying this type of recycled plastics. So it is not the waste. They are getting money out of this waste. That is called a waste to wealth or trash to treasure from trash. This kind of words we will use in for MRF facility. No, whatever we are thinking waste for us, it can be a valuable item for someone else. So it should not be treated as waste. It can be dropped in a respective place or a designated place where the people can collect and you can use as a secondary material for their purposes. So MRF plays a major role in that. And the main motive of MRF is that the output item, that is the deliverable item, should not have 10% more than 10% of contaminants in it. That's the major criteria they have to have. But most of these MRF facility will maintain 5% as the limit, contamination limit. Yeah. First one is clean MRF. Now we are going to discuss about the dirty MRF. Dirty MRF is this one which receives the unsegregated waste from source segregated waste will be going to the clean MRF. If it is receiving the mixed waste, unsegregated waste, then it is called dirty MRF. So it requires 100% sorting. In the clean MRF, we will receive segregated waste, so it is easy to handle. But here we require 100% sorting to sort out different types of waste, and 5 to 40% is the recovery rate of the incoming material as a recyclable, because all the type of waste will come without any segregation. So after segregating the wet waste or the inert waste, then we will get only 5 to 45% as a recyclables. Or what is the advantage of dirty MRF is, dirty MRF has some advantage because it increases the participation rate. If you are forcing the people to segregate at the source and then give to the clean MRF, then the participation will be less. But if you are asking them to drop directly as a commingled waste, then people will participate more. So increasing participation rate. So some of the other waste can be used to prepare fuels and feedstock processing through some conversion technologies. And higher recycling rate, because more input, more recycling rates. And but whatever the already source segregated waste will be, will have low recycling rates, and recovery rate also very high. But disadvantages in the sense it will have greater contamination and challenging process, because to separate wet waste with the dry waste itself is a challenging process, very expensive. Operation cost is high, installation cost is expensive, operation cost is also higher, labor intensive, because separation will require lots of manpower. This is one of the examples for a, material recovery facility in India, in New Delhi railway station, NDRS. You can see the family members of these railway workers are separating the waste in the railway station, and they are paying to the railway station for handling this type of waste, and this supports their livelihood. The people are the waste pickers association called Safai Sena, along with this Chintan, that is the non-profitable organization like a NGO, and internet and buyer and waste trade, that is a small scale trading mechanism. So all these people combinedly is doing a MRF facility in New Delhi railway station since 2012. So advantages is like providing a cleaner working space, and trained rack pickers are collaborated in this, and it's also supporting their livelihood. Yeah, this is a team of waste picker, uniform uninformed carriers. The uniformed carriers you can see in the railway station. They are handling all type of waste, and lots of news articles related to this waste free Delhi railway station. And waste, what they are doing is waste is composted, dry waste is segregated into more than 12 categories and recycled. This itself a big achievement, you can see. 12 um, categories in the means plastic, paper, cardboard, glasses, metals, and some etc. etc. kind of 12 categories they are segregating and recycling. This itself they will generate a lots of money out of it, out of this recycling facility. Only waste which cannot be treated is meat bones or the chicken gravy, that is we will call slaughterhouse waste. This is again the same thing. Meat bones and plastic bags containing filthy items. If the waste is segregated, means plastic bag in one bin and meat in another bin, it is easy to handle. If it is mixed, again it will be only taken to landfill. There is no other option for processing. And NDRS does not pay any amount to these people, Safai Sena and Chintan. But compost selling itself will give them 15 rupees per kg free of cost. That is given by Safai Sena to the railways. Yeah. And another video Sarah has shown in the lecture related to Indore. You know, Indore is the cleanest city based on the Swachh Bharat report. For last this many years, Indore is maintaining the status. You can also go through Swachh Bharat website for more details. Indore is the cleanest city as of the Indian ranking. How they are handling their dry waste through the MRF facility, you can go through this video. Yeah. But what are the consideration we need to do? Engineering consideration and environmental consideration also there. What are the engineering consideration we need to take care while designing a material recovery facility center? Yeah. First is selection and function. What is the role of the MRF, and what are the types of material it's going to handle, and way of material delivery, where the material will go after separation, and way of presentation to the buyer. These are all different things we need to first fix before designing any MRF. What is the role first? It's going to handle only the paper, or it's only handle. This is what I have discussed about clean MRF. In the clean MRF, dual MRF, paper MRF, and single MRF. These are all the different things we have discussed now. So, what is the role? First, we have to fix. Then, what are the types? Based on that, different bins we need. Different types of concrete tanks required for segregating different 12 categories or 20 categories of waste. Plastic itself will have 20 categories. Not only plastic, paper, cardboard. Plastic itself will have 20 categories. So this many types. What are the things we are going to? So the proper planning and data sheet is required first. And selection of materials, where we are going to collect the waste. Identification of material specifications. So based on the specifications only, we can easily segregate the waste. How to find this is LDPE plastic? How to find this is a HDPE plastic or a PET plastic? That identification is very important to design any MRF. Then development of separation process flow diagram consideration. The flow diagram we are going to discuss in the upcoming slide. It is like a simple flow diagram after inlet, how it is going to separate. First plastic, paper, cardboard. Then from the plastic bin, we are going to separate into different plastic, lightweight and heavy density. Then from heavy density, how we are going to, this type of flow diagrams is required based on the characteristics of the waste and material specification chart. Each material will have one material specification chart. Based on that only we are going to recycle. Then what are the equipment available and the manpower available? Without equipment and manpower, we can't do anything inside the solid waste management facility. And then process loading rate, how much MRF can handle in a day, 100 tons per day or 1 ton per hour. This kind of loading rate or the capacity of the MRF is should be fixed. Based on that, we have to collect the waste from different areas. Then layout and design, like material waste deliverable, the pathway, loading rate, material flow and handling patterns. These are all need to be considered for designing any MRF. Then selection of equipment, environmental controls.
There also leachate will be generated. There also air pollution may create aesthetic consideration. And this and all need to be taken care while designing MRFs. Again, as a engineer point of view, it's okay. Then planning and design point of view, feasibility, technical and economic merits. I am considering. I mean, I'm constructing a MRF, but what will I get out of it? By processing 100 kg of 100 tons of waste per day, how much rupees I will get by selling different types of waste after segregation? So per kg of segregated plastic will be this much rupees. Based on this economical merits only, I have to do cost benefit analysis. I have to find net present value. Then only I have to design any go into the construction of MRF facility. Yeah. Ownership. This plays a major role. Who is the owner? Like what we have discussed in the New Delhi railway station situation, the people and the NGO and the private party, all three together working as a whole. There is no ownership kind of thing. Who will? This is the kind of collaboration. This type of public, private, and a people combination, that is called PPP. Public, private, and the people should collaborate, and they have to participate in the this kind of activities. That is public private participation, PPP participation. Yeah, this is the mass flow diagram for example for MRF. After receiving any waste, how much waste is there, how we are going to segregate, and what this is like mass balance. Whatever the inlet should be equal to the summation of segregated waste. 100 kg is getting in 10 kg of paper, 10 kg of metal, 12 kg of plastic, 8 kg of glass. All added should give you again 100 kg. Otherwise, there is some mistake in the segregation. This should not be, there should be a proper mass balance. Then what is the issue with the MRF? Okay, these are all okay. I can do MRF, I can generate money. But what are the issues? People will allow, people allow construction of this MRF inside their premises. That's what the NIMBY syndrome we will say. In abroad, it is very common in US and all. NIMBY is not in my backyard. No people will allow this type of processing facility in their backyard. So citing location for the construction of MRF facility is a critical task for any engineer. Where I have to construct that. If it is far away, then again transportation cost will be higher. If it is very near, then people will object. Environmental issue will be there. So there should be a proper optimal place. It should be at the outskirts of the city. Yeah, there should be a proper optimal place. The MRF should be at the outskirts of the city, which should not be very far away, and which should not be very near to the city also. Yeah, there is a guidelines given by the Asian Development Bank for the Philippines for MRF siting consideration. It should be very close to the existing road because all the vehicles should easily access the MRF facilities. But traffic movement should also be taken care. No traffic should be there at that place of MRF siting locations and near and within the urban areas. This is what I have discussed. But it should not create any issue to the public. It should be away from 100-meter away, minimum 100-meter away from the buffer zone. Buffer zone in the sense hospitals, schools, sensitive areas, you can say, park, residential areas. So it should be minimum 100-meter away from the buffer zone. Yeah, preferably located in an industrial zone and close to the sanitary landfills. If it is near the industrial zone, it is easy to transfer after processing because industries are ready to buy this type of processed recyclable items, and it should be very close to the sanitary landfill because whatever the residues we are getting 5 or 10% residue that can be easily sent to the sanitary landfill with the low cost of transportation. And the location should be very flat. It should not be having any slope. Gentle slope is acceptable, but it should not be very slope. This kind of complicated condition need to be avoided. It should reduction of it will reduce the excavation cost and stable area. It should not be any earthquake prone zone or any flood prone zone should be avoided. Yeah, and environmental issues like traffic, noise, dust. As I mentioned, particulate matter inside the MRF is a concern. So people or the labor working inside the MRF facility should be properly hand taken care with the proper mask and hand gloves and all the personal protective kits should be provided. Yeah, these are all environmental conditions. Along with that, other because biodegradable or wet waste is also mix with the dry waste and come to the MRF facility. So that should be handled separately. And vector control. Whenever coming with the waste is coming, vector will also come. This type of vectors like mosquitoes or rats, this type of the rodents should be avoided. Airborne litters and all, with the proper fence we can avoid. Public health again, protective clothing, puncture proof gloves, because any sharp items from the hospitals or any glass particles, broken glasses may come. So puncture proof gloves are required. Air filters to filter the particulate matter, and showers are required. The water spray showers to settle down the particulate matters. And then economic point of view, it should be sensitive to market prices, because whatever we are producing, the recycled secondary material should have some value. Otherwise, the whole process will be again non-economical or a waste of time. So it should have a proper value, so sensitive to the market price, and whatever the process cost involved should also be added to the secondary cost, the secondary product cost, and must be environmentally correct. The produced secondary material will be environment friendly, and this whole process is again sustainable way. Anyway, it's a circular economy, so it's sustainable only. But the production should be in a environmentally correct manner, and the product should be environmentally safe. Yeah. Okay. So now we have discussed about the MRF. Now we are going to discuss about recycling. Recycling of different items like paper, glass, metals, and aluminum cans separately. Yeah. You know recycling from your childhood onwards. We have studied what is recycling. In Solid Waste Management Rule 2016 also, a definition is given. The definition of recycling is the process of transforming segregated solid waste into new product, or a raw material for producing new product. That process is called recycling. Whenever I am having any paper, that paper can be, if it's treated as waste, then it can be converted into a pulp again. Then the pulp will be used to produce any new material, or it can be a raw material for production of new material. Then it is called, this process is called recycling. It will be applicable to any type of waste materials. Yeah. Once again. Yeah. What are the advantages of recycling? We know recycling itself huge. It will reduce a huge carbon footprint, or what we can say, it's a more sustainable process. Since we are going to discuss about the advantage on different heads. For urban local body, it will reduce the volume of the waste, because I am creating one paper waste. I am printing one paper. After it use, I am going to discard. Instead of discarding, if I am reusing for some other purpose, then it will reduce the waste volume that is going to be handled by the municipal authority, and the cost for collection, because instead of 100 kg, if I am producing only 50 kg, then cost for collection and transport of 50 kg will be reduced, and this is a huge burden relief for the urban local bodies, that is the ULBs. Okay, then longer lifespan for landfills and reduced environmental management efforts. This and all advantages for the ULBs. Then in the economic point of view, as I mentioned, reduction in the import of raw materials, because I'm again using the same waste paper for production of new papers. So I don't want to cut some other trees for virgin materials. So reduction in the import of raw material and fertilizers. Then livelihood opportunities for the recyclers. Yeah. Because I am creating some job, recyclers job. So it's a livelihood for them. This is again an economic point of view, or a societal point of view. Then environment side, it's a sustainable way, circular economy, it's promoting, and reduced waste volume for the, and the reduced land area. If I want 1 acre, I mean 50 acres of land for landfills or any disposal dump site, then instead of 10 acres, I can record only 10 acres, because I am recycling some of the waste that is generated. So again, land requirement is reduced volume, so height will also get reduced. These are all advantages of recycling. First, I am going to discuss about plastic recycling. Yeah. So as you know, we have, as I mentioned, there is a code word for any type of plastic. So if you have any plastic bottle nearby, you please take any plastic product. You just check, there will be a number inside a triangle with a symbol of recycling. There should be one number that mention what type of plastic and whether it could be recyclable or not. That can be mentioned with this type of number. So there are 7 numbers, 1 to 7. So 1 is easily recyclable, 7 is very hard to recycle. So now I am having one a plastic Fevikwik in my hand. It is mentioned as 5, 5 with a triangle. That is mentioned PP, recyclable for container. So the Fevikwik is made up of PP plastic, that is polypropylene plastic, which is in the 5th category of recyclable, but it is recyclable. That is what mentioned in this. So 5th plastic container is PP, that is recyclable. That's what mentioned. Any product will have this code number. Why 1 is easily recyclable and 7 is not recyclable? Based on the polymer type and easiness to recycle, the code word was given, and from the ascending order, it is easy to recycle. That's the that is the criteria logic behind the numbers. So 1 is PET, 2 is HDPE, polyethylene tetrathalate, and high density polyethylene. Third one is PVC. What are the pipes we are using for the water lines? Fourth one is LDPE. LDPE is the carry bags what we are using. And fifth one is PP, polypropylene, what we are using for the battery cables, brooms, ice scrapers, rakes, and all. And then polystyrene is the sixth one. Polystyrene is used for foam packaging. This and all it now banned in Tamil Nadu. Tamil Nadu we have banned single-use plastics and all. So LDP is purely banned, less than 45 micron in size. Yeah. And then seventh one is others. Others in the sense multi-layered plastics, mixture of two different types of plastics, and then BPA, bisphenol A. You have seen some of the plastic toys for the kids. It will be mentioned BPA free. Some of the plastic water bottle, if you see, BPA free, because BPA is very carcinogenic. So now people are manufacturing. Yeah. Now people are manufacturing plastic without BPA, that is bisphenol A. So we have 7 categories of plastic waste based on easiness of recycle and based on the polymer used for the production of plastic. One is PET, 2 is HDPE, 3 is PVC, fourth is LDPE, fifth is PP, sixth is PS, seventh is other type of plastics. These are the 7 group of plastic. But the main thing is not all 7 group of plastics are recyclable. That is the point we need to note down. Not all the 7 types of plastics are recyclables. Yeah. How? What are the different stages in the plastic recycling process? First one is segregation, because it may be if any combined waste is coming to the MRF facility, first or a recycling facility, first we need to remove the contaminants or any type of different types of waste that is coming along with the plastic waste, that should be segregated. Then washing. Washing will remove the type of plastics or the adhesives present in the because any, if I am buying any soft drinks, there will be a label above it, and there should be, there may be having any adhesives to stick the labels. So I have to wash to separate, because the soft drink bottle is one type of plastic, and the soft drink cans is one type of plastic, and whatever the neck part we are having, the one clip, that is the one type of plastic, and the label is one type of plastic, and the adhesives is different type. So we need to separate all of this to for proper recycling and proper marketing of this recycled items. And then third one is shredding. Shredding into smaller particle will reduce the handling cost and the storage cost. Because if I am transporting 100 water bottles, then it will require a big container to transport. But I am shredding and making into a smaller particle, then one container is enough for storing all the 100 water bottle pieces. Yeah. Additional step is to remove non-plastic waste. If I am shredding and sieving, then easily bigger particles which is not able to shred, that can be easily segregated. That is the non-plastic waste. Then identification and classification of plastics is based on different types of tests. One first test is like a density test. By floating, as we know, plastics will float because it's having low density than water. Some type of plastic, type of plastic will float at the center of the water based on the density. So done by floating the particles in a large tank of water, particle lighter than water will float and then will sink. That can be easily identified. Metals and all will sink. That can be easily segregated. Then air classification test. LDPE can be easily segregated from the HDPE plastic with the air flotation. The small wind tunnel is required and the air can be blown and light density particle will blow off to a separate place and HPP will fall into the nearby places. Again, density test can be used to separate types of plastic itself. As I mentioned, one plastic will be having 1.2 density, some will have zero point 0.9 density. So 0.9 density will float, 1.2 will sink, and one will be at the center, can be easily separated. Yeah, that's the density test. Then extruding and compounding. This video you can go through. After segregating all the type of plastic, it can be easily extruded, and we can make a what we call, with the application of heat and with the screw conveyors, we can get a thread kind of thing with the plastic, and then we will get smaller pellets. You can see in this photo, he is feeding all this shredded plastic into the hopper, and it will heat the plastic, and with this type thread will come out of the plastic. After cooling with water and cutting into smaller particles, we'll get this type of pellets. So these pellets are used as a raw material for production of virgin plastics, not virgin plastic products. So this is what they are following in all type of recycling plants in India, plastic recycling plants in India. So whatever the plastic we are getting, we can easily shred and fed into the extruder. We are having different types of extruder. So twin screw extruder, and then direct compressor. By direct application of heat, we can form any type of shapes with this type of plastics. Again, different types of plastics will behave differently. You have to choose the right kind of plastic. Yeah, you can see the global scenario. Initially in 1980s, the manufacturing, the plastic discovery led to many industrial development after 1980s and all. So there could be 100% plastic, means 100% will be discarded only. So gray indicates the discarding thing, and red indicates the incineration thing. Then blue indicates the recycling thing. Up to 1990, that I mean 1990, there is no recycling discovered. Only whatever the waste, somewhat is collected and somewhat is incinerated. Other than that, was discarded only. But if you see in 2015, 19% is getting recycled, 25% is incinerated, and only 50% is discarded. Still, we are working on it to recycle the whole 100% of the waste, plastic waste collected. Yeah, you can see different news articles. India recycles 90% of PET plastic, because PET is very easy to recycle. Whatever the water bottles we are using are all PET bottles. Okay, so these PET bottles are easy to recycle. Outperform Japan, Europe, and US. So this data itself a huge success for India's recycling initiatives. Yeah. Again, plastic recycling could the future be in India? If you see in some of the data or some of the articles says in 2100 and all, this recycling sector will overtake the IT sectors. Whatever now IT sectors are blooming in India or worldwide, IT sectors are blooming. But if you see in future, this recycling sectors or plastic, not only plastic, solid waste recycling sector will be the future I mean blooming sector. That is some of the research articles I will also post in the problem solving section folder. You can go through the some of the articles I will post. Yeah. Then after plastic recycling, I am going to discuss about the metal recycling. Metal in the sense major steel and iron is the major metal we are going to recycle. And in the recycling facility, iron and steel contribute 86% of the whole recovery. I mean recyclable items. And steel is the world's most recycled material with the 86% in 2014. Again, not only that, what is the economic development it is giving? You see, in India, the metal recycling sector contributes around 2% of the GDP. You see how much amount also we are getting out of this recycling plants and that. Okay. Again, if you see, India recycling 60% of plastic, 27% of paper, and 25% of metal, which is again very lower than compared to the US and even global. So globally, they are recycling lots of paper. I mean metals. Compared to US, we are also still in the lower rate. Yeah. And then aluminum recycling. Aluminum recycling in India contribute to 25%, but the worldwide average is 40%. Again, we are in the lower side only. Some of the news article mentions aluminum scrap seeking respect in India. So still, Indian recycling sector is still blooming, and many type of recyclers are coming for different types of waste like aluminum, paper, plastic. Everything is getting nowadays. Entrepreneurs are coming and recycling different types of waste. Yeah. Stages in metal recycling. First, as I mentioned, first we need to segregate, shred, melt, then purify. Solidification, transportation of this metal bars. After solidification into a proper shape, the metal bar can be easily transported to the industries, those who are in need of the secondary materials. Then glass recycling. So whatever the crushed waste glass, we will call as cullet, C-O-L-L-E-T, cullet, not the glass. This is called cullet. So there are two types of cullet. One is internal cullet and one is another external cullet. Internal cullet is composed of different defective product. Once the glass is broken, then it is called internal cullet. External cullet in the sense waste glass are reprocessed with the process of which is whatever the gas that is coming that is processed into smaller particles, that is called external cullet. Whatever we are getting as a defective product, that is called internal cullet. Understood? You got the difference, I guess, internal and the external cullets. Then end of waste cullet is the external cullet only. Whatever we are processing and so end of the waste, that is called external cullet only. So it is again having different types based on the color, based on the material used, and based on contamination also. There is having some stickers and adhesives again sticked over the glass materials. It should be purified, cleaned for contaminants. Recycling rate for glass is 35%, which is again comparatively lower compared to the global situation. Yeah. How to recycle this type of glasses? First we have to segregate based on color, based on material, based on sizes. Then glass breaking, as I mentioned, glass breaking will shred the waste into different particle sizes. Then Trommel screen is used to segregate the waste based on segregate the shredded glass particles into different sizes. As I mentioned, this will be 2 mm, this will be 6 mm, this will be 10 mm. So after shredding, if you feed, we can get different types, and whatever is greater than 10 mm will fall out of it. Yeah. It is like a drum, it will rotate. Yeah. Then fluidizer bed dryer. Bed dryer will apply some heat after washing. So this heat will be used to loosen the label glue, and then the label will come out of this, and the residues will float out the top of this, and it can be easily removed. Then primary rotatory screen, pulverizer. Pulverizer is having some hammer. It will be used to shred the waste, glass waste. Against the secondary rotary screen, trommel screen, rotary screen, everything is used to segregate the glass waste based on sizes only. So this initiative, we are all aware of. Some of the team in Delhi uses discarded glass bottle to make stronger sand for construction. We can use any type of waste, shredded waste, as a replacement of cement in concrete. Many researchers are using plastic waste, this type of glass waste, tire waste as an alternative for not only alternative, as a admixture for concrete production to increase strength. As a civil engineer, many of the structural people are working on adopting different construction material from the waste. Yeah. And cardboard recycling, as you mentioned, different types of this is the bulk waste. We can say cardboard is a bulk waste. It will accommodate a larger volume of in the waste handling sector, and reuse of thick sheet and stiff multi-layered papers are the problems. Again, this process consists of sorting into box boards and corrugated boards. Box boards in the sense cardboard, ring containers, and cereal boxes. Corrugated boxes like bigger and stiffer, commonly used for packaging transport goods. So small milk packets, cereal boxes, and all box boards. Bigger packaging material are called corrugated boxes. That should be sorted initially. Again, shredding and pulping, as mentioned in the paper, we can use for production of smaller packaging item. And one of the video also I will share in the problem solving session with the link. You can go through that. Some of the people are making some zigzag or honeycomb structure with this type of recycled cardboard boxes that can be used as a cushion packaging materials. Okay. Then filtering and de-inking, because some of the cardboard may have color and packaging materials may have color, and finishing for reuse, like a heated cylindrical surface will be used to make different products. Yeah. So again, and paper and cardboard in stands 66% as a recycling rate in 2017 in US. Again, paper recycling. Paper will have three type of recycling papers. One is Millbrook, pre-consumer waste, post-consumer waste. Millbrook in the sense, whenever the paper manufacturing itself, we will trim. If we want a A4 sheet, if I produce the paper, I mean paper production itself, they will make a big sheet and they will cut into different shapes. After cutting all the A4 sheets, whatever the leftover, that is paper trimming. In the industry itself, that is called Millbrook. uh, the leftover from the paper mill are called pre-consumer waste. Before coming into the market, whatever pre-consumer waste, that is called means paper mill waste is called pre-consumer waste. After we use whatever we are discarding, that is called post-consumer waste. Old corrugated papers, magazines, newspapers, and all. So we have three types of recycled paper: Millbrook, pre-consumer waste, post-consumer waste. All are handled in the same way: collection, segregation, bundling. Bundling is required to easy transportation and reduce the cost of transport. Shredding in the sense with a blender with some of the chemicals which will digest the paper and it will be made into a pulp. Then fifth is pulping, sixth is washing, then de-inking. De-inking and bleaching will help you to impart this white color into the paper. With chlorine bleaching, some of the green chemistry will talk about different kinds of non-toxic chemicals used for bleaching. Then drying and then pressurizing will give you a proper paper. Then rolling and marketing. This is the recycling stages of paper manufacture. I mean recycling. Again, paper also compared to US and global condition much lower in the recycling rate. We are only 27 recycling only 27% of the paper waste produced. Yeah. After discussing all this type of recycling item for paper, metals, glass, plastics, whatever the product we are using, that should be have a good accessibility and a market value, and it should be environment friendly. Otherwise, the whole recycling or the processing the whole process will get uneconomical or it will be a waste of time. So there should be a market available for the recycled item or the secondary material what we are producing. Then only we have to go for recycling. This type of dry waste, only recycling is good option and it can be done with the MRF facilities. That's what we have discussed in this lecture. So as an overview, today we have discussed about transfer, what are the vehicles we have used, and then a transfer station design consideration, and we have discussed some of the mathematical equation to optimize the cost to transfer waste from transfer station to the disposal site. Then we have discussed about process of waste, not the transformation. Transformation is the volume reduction or weight reduction. Processing is only physical mean: shredding, screening, air classification, density classification. This type of physical means we have discussed today. And finally, we have discussed about the MRF and the recyclings of waste plastic, paper, cardboard, glass, and aluminum. Yeah. So now we will discuss about the old assignment problems. If you have any doubt, please post it in the chat box, or you can also unmute and you can ask. Yeah. If you have any doubt related to the lecture, you can ask. Otherwise, we will go to the problem solving session. Okay. So I'll discuss the problem. If you have any doubt, you can ask anytime, no issues. So I'll read the question. You can post the answer in the chat box. Yeah. What is the requirement for setting up of an economic transfer station? As per CPHEO manual, they have given there should be a proper guidelines for setting up of the transfer station, economic transfer station. The options are a disposal site more than 10 km far from the city boundary and smaller vehicles are used for transportation of the vehicle. A disposal site more than 10 km far from the city boundary and transportation of by railroads. A disposal site 3 km far. A disposal site more than 10 km far from the city boundary and larger dump setter are used for transportation of the waste. Yeah, option A, that is correct. So any like a transfer station should be 10 kilometer away from the our location. Then it should have a vehicle that is collecting the waste from the location to the transfer station is from smaller vehicle. Then from the transfer station to the disposal site should be with the bigger vehicles. That's what this question deals. Yeah. Then it reduces the transportation cost, because if you are transferring the waste from the location to the disposal site with a smaller vehicle, then it will be a large cost associated with the transport itself. So we are disposing the waste in the transfer station, then we are loading into the bigger vehicle, then moving to the disposal site. Yeah, reduce the collection and the transportation cost. Second question is, if the quantity of the waste generated is low, waste separation can be done at MRF, separation at the source, after dumping in the landfill, none of this. There are two categories. If the quantity of the waste is huge and the quantity of waste is low. If it is huge, again there are two options. One is manual, one is mechanical. If it is very less, then segregation at the source is good option. Yeah, option B is correct. Then third question, which of the following does not require size reduction of the waste? Size reduce does not require size reduction of the waste. Reduce storage, reduce shipping cost, to get uniform product, to reduce volume. Yeah, it's clearly mentioned. Size reduction will not reduce the volume. Yes, that's correct. Then fourth question. Screening is the process of separation of the waste of different densities, separation of waste of different volume, separation of waste of different sizes, separation of waste of different mass. So we have discussed different screening options. One is trommel screen, a star screen, screw screens, and ballastic separators with the different types of holes. So it will segregate the waste based on, no, density separator will separate the waste based on densities. But screening is based on size. Yeah, correct, sir. The size is correct. Separation of waste based on size. Yeah. Then fifth question, which type of waste separator is used for separation of light materials from heavy material? Here you can mention based on weight. Screening a density separator, magnetic separator, none of this. Based on weight. Yeah. Used for separation of lightweight material from heavy materials based on weight. So that is called a density separator. That is correct. Yeah. Then sixth question, what is the technique used to store and transport waste cheaply? Which is used to store and transport waste cheaply? Shredding, conveyor, hydraulic and pneumatic system, densification. Shredding will again have same volume as I mentioned. Conveyors only will convey the waste. It won't reduce any cost or something. Hydraulic and pneumatic system is a conveyor system. It won't also reduce any cost. But densification will reduce the volume and it will reduce the transportation cost, because a big aluminum can, like a Coca-Cola cans, aluminum tins, if I have 100 tins, after densification it will become a coin, and I have only 100 coins, it can be easily transported, so transportation cost will become cheaper. Yeah, right. In seventh question, what is the requirement of a waste drop off center? So we have discussed two items. In abroad, in India, we are following MRF, but in abroad or developed countries, we have two systems. One is waste drop-off center, one is waste pickup center. What is the requirement of waste drop-off center? Drop-off center in the sense we have to drop our recyclables, and payback or buyback centers are the one people will come and collect the processed or the clean recyclables for their requirement. So the options are: waste generator is not responsible for carry the waste to the collection station. The waste producer has to carry the waste to the collection center. The waste producer can purchase the recyclable material. None of this. Yes. Option B is correct. Because The advantage of waste drop-off center is uh, people are coming and dropping their waste. So it will reduce the cost of the municipality to collect the waste from the people. So people themselves will carry and drop the waste in the drop-off center. But in buyback center, option C is correct. The waste producer can purchase the recyclable material. Yeah, this is correct. So eighth question is, waste such as HDPE or PET are usually separated by, because these are all high density, HDPE and PET. All these are all plastic items. So we have discussed different items for different separation methods for plastics. Air classification, density blowers, conveyors, eddy current separators. HDPE or PET? Sir, you posted the answer. Answer is A. What is the last question? Yeah. B. This is for A. Yeah. That is correct. Air classification. Because this is purely based on density separation. So we can use water flotation for density separation or air classification. This type of density blowers are used for metal transfer. The eddy current also used for metal separation only. Conveyor belt is not a separation thing. It is used simply a belt used to transfer different waste. Yeah. So air classification and flotation methods are used for plastic separation. Okay. Ninth question. Which among the following are non-recyclable plastic? LDPE, PP, composite plastic, polystyrene, PS. Yeah, non-recyclable in the sense composite itself is non-recyclable. Yeah, that's correct. Because composite is combination of different plastic. If you see any Tetra packs, I hope you know Tetra packs, fruity cans or a Mazda can in a cuboidal paper with a straw. You can see. If you open it and you can see the thickness, you can see 7 layers of different types of materials are used to produce the Tetra packs. One layer of aluminum foil inside to resist the water, I mean fluid movement. One layer of plastic, one layer of paper, one layer of advertisement paper, again one layer of shining sheet. This type of 7 to 8 layers of multi-layered plastic we will say. So these are all very hard to recycle. If it is a single layer plastic, then it is easy to recycle. So nowadays there is a guidelines, proper rule for the manufacturing and uh, handling and processing of multi-layered plastic separate is there, that we will discuss in the upcoming weeks. Yeah. So LDP is easy to recycle, PP is easy to recycle, polystyrene is easy to recycle. Non-recyclable is composite plastic. Not easy, but very hard to recycle. Yeah. What are the stages of glass recycling process? Segregation, breaking, trommel, primary rotary screen, secondary rotary screen, fluidized bed dryer, pulverizer. Can we rearrange? Glass. First segregation is correct. Then breaking is correct. Yeah. After breaking only we have to use trommel to screen. So segregation, glass breaking, trommel. That is correct. Yeah. Trommel in the sense rotary screen, then secondary rotary screen. That is also correct. Then fluidized bed dryer, then pulverizer. No, pulverizer is like again a breaker. So it should be, yeah, pulverizer should be middle. Primary, pulverizer, then secondary. Then only, no, there is a mistake. First we have to segregate glass breaking, trommel. I'll go to the slides. For glass. Segregation, glass breaking, trommel. After that, it's a fluidized bread is coming. Then only we are primary rotary screen, pulverizer, secondary rotary screen. Then final product. Yeah. So in between itself, we are fluidized bed dryer is there. Yeah, that is correct. Option C is correct, sir. Please correct your answer. Option C. First we are segregating, then breaking, trommel is fine. There itself fluidized bed to remove the labels. Then only we are screening and pulverizing, then secondary screening. Okay. Then final product. Then another last year 2021 question paper. Which purpose does not fall into waste separation category? remove contaminants, modify the chemical characteristics, recycling, modify the physical characteristics. Waste separation. Waste separation is a physical process. So it will remove contaminant, it will be easily, recycling will come under this, and the physical characterization modification is correct. No, sir, not C. Can you please check? Waste separation, not transformation. Waste transformation will be a chemical process, but this all what we have discussed is all physical process. So it will remove contaminant by separation, segregation. It will be recycling. It will modify the physical characterization like density or all. No, sir. Option B is correct. Modify the chemical characteristics. It will not. Answer is not. What they are asking is which purpose does not fall into the waste separation category. So option B. Hope you got it, sir. Yeah.
Sir.
Okay. So the question is which purpose does not fall? Okay. Yeah. So the second question, multiple option question. Please look into it. Size reduction of waste is done to. Why we are doing size reduction? To reduce the volume, to obtain uniform product, to reduce shipping cost. None of this. Size reduction. C. That is correct. C is correct. And uniform product. That is also correct. Yeah. Because after shredding, we'll get a uniform product. We'll go to the slides once. The shredding. It will reduce storage and shipping cost. Also, uh, process of shredding will obtain uniform final product because all will be in the same size. Whatever the glass bottles we are getting after shredding, everything will be in the same size. That's the concept behind size reduction. So if you are getting only one option, then when you get zero point 0.5 points, 0.5 marks. Yeah, multiple option question. What is again a multiple option question? What is used to push the waste into the transfer vehicle in direct load transfer stations? These photos we had seen. Rubber tired rigs, tractor, overhead clamshell crane, none of this. Used to push the waste into the transfer vehicle. Mhm. I don't think so. Pushing the waste into the vehicle. First itself we have discussed. Yeah, here a hydraulic system, rubber tire trucks, and also overhead clamshell is also correct, but rubber tired rigs also we have to look into. Both are required. I mean, both are used to push the waste into the transfer vehicles in direct load transfer stations. Direct load in the sense directly from the smaller vehicle to the larger vehicle. Then fourth question, which of the following method is used to separate the metal from the waste? Metal separation, density separation, gravity separation, screening, magnetic separator. Yeah, this is very easy. If you see metal is majorly steel and iron. Steel itself will contribute the major part in the recycling sector. That can be easily segregated with the magnetic separator. Yeah, correct. Then fifth question, dash method is used to separate plastic from the commingled waste. Commingled waste in the sense mixed waste. So which method is used to separate plastic from the commingled waste? Density separation, gravity separation, screening, magnetic separator. So screening, um, magnetic is not there. Okay. Gravity separation is air blowing. That is not all correct. The density is used to separate different types of plastic by water flotation. Screening, okay, density separation is correct. Because screening we can use for different types of waste. Yeah. In sixth one, which center enables the resident to purchase the recycled material? Back off center, buyback center, drop off center, none of this. Correct. Yeah. So there are two options. I mean, there are two options. One is drop-off center. The people will come and put their recyclables. That is dropping. Then people who need the recyclable, cleaned recycle waste, they will come and get. That is, they will come and buy. So buyback center. That is called buyback center. Is maybe option B is right. The seventh question. Uh, Multiple choice question. Please look into it. Multi-resource facilities are specialized at multi-resource facility or MRF, material recovery facility, are specialized at receiving waste, separating waste, marketing recyclable waste. None of this. You can take many options. Sir, you can take many options. So MRF will receive, it will separate, it will market the waste. So all the three are correct. Because MRF will receive the waste, it will only separate the waste. It will only market the waste, market the recycled material. So option A, B, C are correct. Please look into it. Yeah. The last question. What is the sequence of plastic waste recycling? Segregation, washing, shredding, identification, extruding. Plastic first we need to identify, compounding, washing, segregation, shredding. No, no, no. Washing is correct, then segregation, then shredding, compounding, identification. Can you go to the lecture video? Segregation, washing. That is correct. Okay, segregation, washing, shredding, identification. Then only we need to extrude. Correct. Yeah. Mm. Final one is extruding because we are extruding into different product or a raw material, pellet. What I have shown. Can go through the lecture video for plastic. For plastic recycling, first we are segregating, then washing the containers for label and packages, then shredding into smaller pieces. It will have additional steps to remove non-plastic items. Then we are identifying. After segregation only, we are identifying with the density test and the air classification test. Then only extruding into the plastic pellets, kind of this. Okay, so option A is correct. Segregation, washing, shredding, identification, extruding. Yeah. Thank you so much for joining the session. We came to the end of the session. If you have any doubt, please ask, unmuted. You can ask, or you can put it in the chat box. You can also ask in the discussion forum. I hope you all know about the discussion forum. I will show in the screen. Yeah. If you have any question, you can ask in the Q&A session. You can ask through your email IDs in the municipal NPTEL Swayam portal itself. And the last date for exam registration was yesterday. I think it was extended. Exam registration, yeah, it got over 16th August itself. Yeah, sorry. So those who are registered, please do your assignments on every Wednesday, even means before every Wednesday. Okay. So this week you have to go do fourth week assignment before tomorrow. Yeah. I hope you are enjoying this session. Thank you for joining. If you don't have any question, you can leave the meet. Thank you so much.
Thank you, sir.
Thank you. Thank you for joining, sir. I'll be in the meet for next 2 minutes. If you have any question, you can ask. Yeah. And the recordings will be available in the Swayam platform itself at the bottom session. After fifth week, you can see problem solving session. You can access my recordings, and another two PMRF scholars are also parallelly taking this session in Saturday and Sundays, I guess. You can also access their videos and their lecture materials. Yeah.
Sir, I have two questions, sir.
Yeah, please.
The
Yes,
first
sir.
one is that suppose if I did not did assignment paper,
Okay.
so the next week may I appeared in that assignment?
No, there is
Actually,
a deadline. There is a deadline.
okay,
For fourth week, tomorrow is the deadline.
okay.
So if you,
Um,
I will just show. Go to the course. So fifth week also is open now. You can also go through the fifth week's video, but the deadline for the fifth week assignment is next Wednesday only.
okay, sir.
So you have to do the
So,
assignment, and as per the course plan, at minimum you have to do 8 assignments because it's 12-week course. Best of 8 assignments they will take for average. That will be 25% of your total mark.
okay. And the second thing is that, sir, suppose um, if I'm not appeared in the classes, means
Okay.
whatever
No,
the
no.
time you have
Uh,
mentioned,
this is not
so
mandatory, sir.
it is not mandatory.
Yeah,
Okay, sir.
problem
So
solution is not
sometimes
mandatory.
okay, sir. And the final examination is 26, sir.
Yeah, 26th of October.
Uh, so all the question will be related to subjective or objective also, sir,
No, it will be
or both.
only objective type, like multiple choice question only. Some may be
Okay,
fill in the blanks. I don't know. Maybe I am not directly connected with Ajay sir, but it's about sir's decision only, Dr. Ajay Kalam sir's decision. But purely it will be
okay,
objective type, I guess, majorly. If it is numerical question also, what we have discussed in the last week, problematic also, it will be objective type only,
okay, sir.
maximum.
Actually, sometimes I am actually before last class, sir. There are some problems
Yeah,
related with the numericals.
they will give
Okay,
some A4 sheet so you can do the calculation and the answer will be four. You can choose one option in the four. That only the thing. So no, it won't be any written
okay,
exam.
okay, sir. Actually, I have already made the payment day before yesterday. Means
Okay,
on
okay,
before on 16th, sir.
okay,
So that's why actually I am not
okay,
much
okay.
concerned.
So you please do the assignment, sir, and you have to appear for the
Yes, sir.
exam for the certification. Yeah, that's it.
Okay, sir.
It will be
Okay.
objective only, I guess, because it's solid waste theoretical paper only. Some of the problem will come, but that is also objective. You have done the assignments now, it will be like that only. One question with the four, the proper full question, and the next four question will be based on the same question, like that data will be given. It will be like that only. Mm.
Okay, sir. During the assignment paper, whatever the question you are asking, the same type of question is asking, sir, in the final exam.
Exams. Actually, that is also I am also participant in this course and the TA. So I don't have direct connection with this question papers and all. So I am taking
Okay.
last year and before that year's old assignments I am teaching, and maximum usually in NPTEL I would have seen like 50% of the questions will be covered from assignments only maximum. So if you go through the lectures, you can easily attend all the questions, sir. Maximum 90% you can get easily. If you go through
Yes,
all
sir.
the lecture videos, easily you can get that. Yeah.
Actually, day before yesterday, I downloaded all the papers, sir,
Okay,
and it
okay,
is 1,000, uh, approx 1,000 or more
okay.
pages are there, sir. So,
Pages. Oh, okay,
during
okay.
the,
No, no.
it is a very
You can follow the PPT, not the book and all. The PPT you can easily go through. My PPT also you can go through. I have noted some highlighted some points or the lecture material what sir had posted. You can. I will show you all courses. Sorry. I'll go to the course and then here you can see the. Here you can see the download option. That download videos and the text transcript. Sorry, every week you can see the lecture note. In that you can see the PPT. That PPT only I am also
okay.
following. So that will be very easy. Like every week it will be 100 pages.
Yes, sir. It
Again,
is very in short.
uh, again in 12 weeks if you compile it will be 1200 pages. So don't compile. It will be very easy to follow. I have posted a compiled PDF of 1 week. That is easy to follow. So you can follow my thing also. The same what the lecture
Okay,
presentations are given. Yeah. So you can if you are not able to attend my live session, you can go through this column, problem solving session, and then here you can see problem solving session recording videos.
Okay, sir. Some days what happens, sir, in the office,
Yeah, I understood,
I
sir. I understood, sir. Yeah,
come late, sir, and after that, today the
understood,
same
sir.
scenario is there, sir. The
Understood,
traffic
sir.
is
Yeah,
very.
you have joined 7 o'clock. No issues, no issues, sir. You can easily go through this lecture. 1 hour, I'm taking all the 4 or 5 videos, so you can also go through that or the same video what sir has posted.
Okay, sir.
Yeah. Thank you so
And
much, sir.
sir, actually, if
Yeah,
I want your mobile number, is it possible, sir?
yeah, please, sir. You can note from here.
Okay. So sometimes because I have some problems, so that's why when
Yeah, you can
nobody's
contact me, but
resolved
it's
the
not
issues.
official. But you can contact me, no issues.
Okay, sir. Okay.
Okay,
Okay.
okay.
Thank you very much, sir.
Thank you, sir. Yeah. Thank you so much. I'm closing the video. If you have any doubt, you can ask.
Okay, sir. Okay.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you so much, ma'am. I'm closing the meeting.
Okay.